Most data scientists, machine learning engineers, or anyone who typically works in Python in a kind of learner's environment, or they want to maybe do some research, it's an iterative process where you have to do some exploratory data analysis, you have to train models, and you have to go back and forth to do hyperparameter tuning, iterations, kind of get a sense of the data, see how the model behaves. And Jupyter Notebook has long been one of the best frameworks or environments where you could develop code. So I remember back in the days, I used to do MNIST data set. You would import PyTorch. You would check if like GPU is available. So you would check the CUDA is available. Is it true? Is it not? Then you can proceed to further steps. I want to argue that Streamlit, which is kind of advertised as a front end, back end user interface web app creation framework. This could actually replace Jupyter Notebooks for a lot of people because of its hot reload or hot module replacement. Very similar to Jupyter Notebooks, it has many advantages, which I'm gonna go through in this video. So I'm gonna follow a particular coding task, which is MNIST data set. I'm gonna get it from my website. This is from a course I taught at HEC Montreal. I think it was 2023. So the content might be a bit outdated, but it can showcase some of the positive aspects of Streamlit over Jupyter Notebook. So you see, it's a full code for training MNIST using convolutions 2D, and then we go to CFAR10. I don't know if I can cover the whole thing, but I'll try to cover as much as I can. I just want to showcase back and forth Jupyter Notebook versus Streamlit. So typically in a Jupyter Notebook, you have your full screen open, and then you would go to something like Torch Vision, get your data set. So like from Torch Vision data sets, you would import MNIST. And in this case, you would get the data. So MNIST, where's the root directory? Let's put it in the data folder. And then it says where's, is it train or not? Let's just get the train split. I'm not gonna do any transforms, but I'm gonna check if I don't have it. I wanna download it first. And then wouldn't pass any basically transforms or kind of disable transforms. So here, the thing I wanna do is just have a look at the data. That's the first thing we usually do. Kind of look at the attributes, see what we have here on the training data set. So we have classes. Let's have a look. So it's a kind of a text saying 0 is 0. And then you would have your X's and Y's. I believe X was in the data. It is. It's a PyTorch tensor too. And you would usually say, what is the shape? 60,000, 28 by 28. Data, and I guess labels they call targets here. The targets. Let's do a shape for that as well. 60,000 examples. So this is your Jupyter Notebook, and as you code more and more, it will grow, become hard to manage. And also, if you want to showcase it to someone who's not technical, or even someone who is technical but they don't appreciate scrolling through thousands of lines of code, that's where Streamlit comes in. So the project directory looks pretty straightforward. I have a minimal example here. I usually don't put it on full screen, and I'll tell you why. And this is perfect for a widescreen if you have a widescreen monitor. So this is my src folder, streamlit app.py, and I just put a skeleton here. Import Streamlit as st, define the main function, that's what's gonna be displayed if it's run as a script. And right now I'm just passing. So let me see if I can execute this. I have a bash terminal here, and I would just run Streamlit application. So this is pretty typical. Console the documentation to set this up. And it's gonna spin up a local server, on port 8501. So let me open that up. So Streamlit 8501. So obviously there's nothing here. Now you see the reason I have put the VS Code and my browser side by side, because I can type in some code here and let's say show some info to the user, like welcome. And I can see it immediately as I save the file, it will reflect here. So that's the main part where I'm saying it's much more suitable for ML engineers, data scientists, to basically replace Jupyter Notebook. Okay, so let's do the same thing we did before. Now, obviously, there are some considerations to keep in mind here. So in my notebook, for instance, I imported Torch, checked if the CUDAs was available, and then got some data set. So you typically put your imports in the beginning of the file, and that's kind of good practice to keep your files clean. So let's go back to the browser here. So let me get rid of this part, import Torch, and I want to put in the main function. Torch CUDA is available. You see, I don't do any prints. I don't put it in any fancy UI, basically. Let me just double check. Torch CUDA is available. Probably there's a misspelling. Is available. Okay. And then when you save it, this is gonna be a Boolean. So let's say has CUDA. And then you would basically write it to the screen. You say stwrite has CUDA. And there you go, true. So you see the output as you go. It has that interactive feel to it. Now, obviously, unlike Jupyter Notebook, where you run a cell, it will create your variables in a workspace and maintain it there. This will re-render the page from top to bottom. So if your code base grows, it has this downside of if the re-rendering process it's taking so long, you'll have to resort to things like caching your data, caching your models, which is always a good idea. You don't want to reload everything on every re-render. And now another positive aspect is you can have your usual components. So like you can have a checkbox. Let's label it like load train. Let's call it load train. And usually I get autocomplete here, but I have to, of course, set it. My Python interpreter, select interpreter, and the one that's running locally. My screen is too small. I'm not sure if I'm getting the right one though. Let's just double check. It's not showing up. Select interpreter. Basically, I want to use the one that's on this folder, so that's not the one. All right, it's not showing up, so I have to manually enter the path. And now I don't know if I can do a relative path here. So virtual environment, scripts, and bin, or I think it's just python.exe. We'll double check. Yeah, it's not here. So let me get the full path, and I'll just do it outside the screen. So that autocomplete parsing, that's going to speed up the process a lot as well. That's going to be something useful. So I'm just going to get this in, kind of help us out with the documentation, make sure everything shows up. I don't have to go to an LLM to see like what arguments I need to pass, or I can just consult things like the documentation directly as well. But if I want the full path of the virtual environment that's going on here, we have the Python executive here. All right. Select interpreter. Put the path here, basically put in the path. And then you would say python.exe. Okay, let's check the checkbox. Still not loading. We'll come back to it. we'll come back to it later. So for now, if I go back to my Streamlit app, you see this load train variables popping up. Obviously, to look at the documentation, streamlit.io, look at the checkbox, see what's available. The first variable I passed in, load train, that's just a label shown to the end user. Value, that's the default value. True or false. So let's say false. By default, we want to load the test set. Or if you want to load the training set, default is true. Now I can get the output called isTrain here, and basically use isTrain to show the user different options. So that's what I'm going to do. So if you remember from the previous example, let me just copy this over. We had two chunks of code. One of them was train and test. Now, of course, it can create a logic. It can say if is train, get the training set. Let's call that data. Else, if it's not checked, call that the data. Now, obviously, here I need to import mnist from Torch Vision. So basically, we have the output. Then instead of print, which will print the output in my console, I will just say stwrite data.shape. Or I guess the data has its own repra, so let's see. So load train by default is true. And if isTrain gets the data and writes the data here. Right now it's trying to run the code, so it will probably take some time. There might be some peculiarities that I haven't explored, like it re-renders the whole component, so it's best just to cache the data outside the main function here, and then when you call it, you just retrieve it. So definitely things you can optimize. But here it says 60 examples because we said load train, and then if you uncheck it, you get the 10,000 test set examples. So that's pretty handy as well. So not just for the end user, even you as the researcher or data scientist have the flexibility of switching things around, keeping the user interface clean, and then it will massively reduce the cognitive overload. Another thing I like about this is stwrite. Now in Python, you would just say print, stwrite, hot module replacement, very intuitive. And I kind of find it easier to type than basically print. So data. Okay, now we get the autocomplete. It took some time. So let's have a look at the targets. And I know it's a PyTorch tensor, so let's just look at the first 10. Another thing I want to do, because my screen will be populated with a lot of outputs, especially if I come back, I just want to have the name of what I'm printing. Is like the web browser inspect console, the developer console, where you get the name of the variable that you're outputting and then its value. So I put it in a string. So targets, the first 10, you kind of get a look at it. And then, I mean, the next step is just plotting. So I want to have a look at one of these examples. So let's quickly get from, or let's just import matplot, lib pyplot as plt. And the cool thing is they out of the box support plotting. You need to pass a figure to them. So if you just did plt imshow, I don't think that's going to work. So it's best just to create subplots. So you can say my figure and my x is plt subplots. Now my screen is a little small for this part. The autocomplete and docs overlap on it. So subplots, get the subplots. And then you would show the image on the axis. So here, let's just have a look at one. So data, and get one example here. So I would say, give me the first example, and it's a PyTorch tensor. So let me just verify its shape before we do anything else. So right, data 0. Let's get the shape. It's a 28 by 28. All right. So do the IM show on it. And now let's set the title. So set the title to the actual label. So set title to the corresponding. So data targets 0. Set a title there. Still no plot is showing because now you should say st streamlit pyplot and pass your figure to it. So that's the part basically that you will get the actual plotting. There we go. So tensor 7, number 7. You see the figure here as well. So pretty much that's all you need for your exploratory data analysis or typical machine learning frameworks. And obviously in Jupyter Notebook, you would set this index to a variable like I, and let's say initially it's 0, and then you get the image, you get the target, you get the shape and everything else. And you can basically go to your code and just change the number. So let's this time look at index 10, which is number 0. But now again, cool thing, in Streamlit, you can have a number input. And let's say the label is index of data to show. And then you can choose the minimum value, maximum value, especially if you're gonna deploy it as an application. In the long run, it's gonna be useful. So it starts from 0, and the maximum index they can use is data shape, right? So data shape 0. And let's see if it's reflected here. In this case, we have 10,000 examples. So 999, is it valid? You get an example interactively. And then since it is 10,000, if I pick 10,000, that's not gonna be valid. So I should add a -1 here because of 0 indexing. And now if I go to 10,000, select, you get a nice validation here saying, hey, it should be maximum 9999. And here's another cool thing. So if you load the training set now, everything will refresh to reflect that. So we have 60,000 examples. And in this case, your maximum will become 59,999. So you cannot go beyond 60,000, but you can go to, let's say, 50,000 and get that example. So your whole application will change to reflect the training set now. So a really cool thing, exploratory data analysis. You want to do bar plot, other types of plot as well. And also, if you basically want to do some model training, you can try this out. You can get a data set, data loader. Not going to focus too much on the whole data set aspect of it. There are some peculiarities, like some modules get cached. So if I define a data set here, that will initialize, get X and Y. And it has a len method, gives you the number of examples. And if you want to get an item by indexing, it will give you an X and the corresponding Y. If you save this and later on you come here and say, give me the train data or just a data set, and you want to use your data set object, which you just defined, there it is. Obviously, I should not call it data set. I call it, let's say, D. And then when you instantiate, you can pass X and Y. So in this case, it was data for X, data targets for Y, and kind of ST right D. You see the object is created, and now you can get an item from it. So let's get the I that we had before. And that's a tensor. And it's kind of shown in a nice way, basically, as nice as it can get with a tensor. And if you modify this, not only does the image update, but also your tensor. And obviously, after you have your data set, you would want to put it in a data loader so you can go and implement that as well. Give me the data loader. from a data set with a batch size. Let's say batch size is 16. Let's call it DL for historical purposes. And then you can use your for loop. So for example in DL. Again, don't print, just st-write example. And I'll just break out of it because it's a huge data set. So obviously, let me just uncomment this. So we just see one part here. So here we go. Right. The first item in the return tuple is the tensor, the image, and the corresponding batch of 16 data. And next you would have your training script. You don't want your training script to run with every re-render, so it's best just to put it behind like a button. So if the button is clicked, it will train your model as well. So that was pretty much it. Most of the functionalities you need in Jupyter Notebooks is here. And a cool story, I was talking to a colleague of mine, and she's not really into coding. So I had the same setup with like a wider monitor. On the left-hand side, I was typing some code like here, hey, here's how the example looks like. And now let's have a look at the labels. And I was sharing just the browser, the local server, and she was seeing the outputs. So it was really cool. I wouldn't have to say, please ignore my code. I'm trying to write the code in the Jupyter Notebook and share it with her. I would just share the interface with her. And for someone who's not technical, they will appreciate it a lot. And makes my life easier too. Like I can show things to them in real time. They wouldn't have to be bothered or cognitively overloaded with code as well. Really good innovation. Let me know what your thoughts are. Thank you very much.